Hi friends, welcome back. Today we're talking about geometric sequences. Okay, so quick reminder, we talked about arithmetic sequences, and so I have those on here as a cheat sheet as well, but these are the formulas you're gonna need. We're gonna be focusing on this sequence right here, this formula. However, you will need these ones for when you do series and sums, finite and infinite, so you might as well just write them all down so you have it at once. But we're gonna talk about this here, that R stands for ratio, or our common ratio. What are we multiplying each spot by? So we're gonna start with number 1. So for number 1 here, we have 4, 20, 100, 500. Now, if you're looking at this and you're like, crud, I can't figure out how to, what I'm multiplying by in order to get 20. What you can always do is take the second position and divide it by your first. And if you do that, 20 divided by 4, we end up with 5. So our common ratio is 5. We are multiplying each of these by 5. And then I get 20 times 5 gives me 100. 100 times 5 gives me 500. So we're multiplying by 5. As a recursive sequence, the way we would write this is we would say an equals the position beforehand, which would be an minus 1 times 5. So times 5. That would be our recursive sequence. That's not really helpful because if I asked you, hey, what's in position 20, you would have to figure all the way out to 20 in order to do that. So we're instead what we do is we write this rule. And again, that rule looks like this. It is an equals a1 times r n minus 1. And remember, your n is your term number or position that it's in. So we look at this and we say, okay, an is our a1. What's our answer in position 1 is 4 times our ratio, which we now know is 5, n minus 1. You have now written the rule. So there's your rule. That's all you got to do in order to write this rule here. Now, if I wanted to figure out what was, let's say, in the 7th position, I would say a7 equals 4 times 5, 7 minus 1. So that's going to be 4 times 5 to the 6th power. So we do, remember you always do your radicals, or your exponents first, radicals, whatever. Okay, 5 to the 6th power, if we do that, we end up with this large number, and then we multiply that times 4. And so we end up with 600. So if in the 7th position, I would have 62,500, but I didn't have to go and figure it out by doing each one of those. So that's how that rule works. Now, let's see about when it gets a little bit more complicated. Let's say you get this guy right here. You're like, okay, is this an arithmetic or a geometric sequence? Well, in order for us to figure out if it's a geometric sequence, we take the second one and divide it by the first. So a little bit of side work here. We're going to take 3 halves and we're going to divide it by 2. Remember, we never divide fractions. We multiply by the reciprocal. So 3 over 2 times the reciprocal of 2 over 1 is 1/2. That gives me 3 over 4. And if you look, if we multiply 2 times 3 over 4, 2 times 3 over 4, we end up with 6 over 4, or 3 halves when we reduce it or we simplify it. And that's what we have, 3 halves. Now we take 3 halves and we multiply that by 3 over 4, we end up with 9/8. Multiply that by 3 over 4, we end up with 27 over 32. So I have now figured out my common ratio is 3 over 4. So if I wanted to write this as a recursive one, I would say an equals whatever came before it, which would be an minus 1, and multiply that by 3 over 4. That's my recursive sequence. But that's not helpful because then you'd have to, like I said before, do it all the way out. So instead what we're going to do is we're going to write our rule for it. It looks like this. An equals a1 times our rate n minus 1. So we're going to say an equals, so what's our answer in position 1? It is 2 times our common ratio, which is 3 over 4, n minus 1. All right, so that's our rule. Now let's use that rule to figure out what happens in our 7th position. A7 equals 2 times 3 over 4, 7 minus 1. So that's going to be 2 times 3 over 4 to the 6th position. Now, in this case, so 3 over 4, I'm just going to do it as a decimal. You can, sometimes you should leave it as a fraction though, but this is a nice easy decimal because it's 3 over 4. If it was a weird one like 1/3 where it's like 3 repeating, you'd want to leave it in fraction form. But I can do that to the 6th power. gives me that wonky decimal there, and then I multiply that times 2. Okay, that's going to be 3 points. So let's leave this in fraction form just so that we can see. So we end up with 2 times 3 over 6, 4, or 3 to the 6th over 4 to the 6th. So 3 to the 6th power is 729 over 4 to the 6th power is 4,996. And then I've got to multiply that by 2. But remember, I can cross cancel here. I divide this by 2, I get 1. Divide that by 2, and I get 2,048. So I end up with 729 over 2,048. So that's leaving it in fraction term. And sure enough, if I divide that, I get that same decimal that I had before. But it is a good idea to leave it in fraction form. So in our 7th position, so we would say A7 equals 729 over 2,048. Hopefully that makes sense. If you have any questions, leave them below. Otherwise, we'll see you next time.